Good afternoon, everyone. So, welcome to Career Launcher. My name is Naveen, and today we'll continue with our LRDI Basics Part 9 of the series CAT 2025 Target 99 plus percentile. So, as always, we will be looking at one of these sets. We will understand how to go about the set, what to infer from the statements, how to make cases if required, and what should be the proper representation and the thought process behind solving a set. So, without wasting any time, let's look at the question. The following table represents the addition of two six-digit numbers given in the first and the second rows, while the sum is given in the third row. In the representation, each of the digits 0 to 9 has been coded with one letter among A to K with distinct letters representing distinct digits. So if we look at the digits here, there are 10 digits 0 to 9, and the number of letters we have is 10, which distinct letters, they represent different digits. Basically, it means that if A represents 0, then B will not, or any other letter will not represent 0. So this is what is given. Let's see if we have additional information and what kind of questions are asked. So which digit does the letter A represent? Theta. So we should definitely know it. Which digit amongst the digits cannot be represented by the letter D? So there may be scenarios where D can represent certain digits out of the given four. One will not happen. Which digit does the letter B represent? Again, a theta, definite one. And fourth question is similar to the second one. Which digit amongst the digits 4, 6, 7, and 8 cannot be represented by letter G? So it looks like D and G, we may or may not know exactly what it is, but with when it comes to A and B, we would know that. So let's look at the set. So we have two six-digit numbers. When they're added, we get a seven-digit number. So if you think about it, when two six-digit numbers are added, or let's look at single-digit numbers. So if we have two single-digit numbers and when they are added and we get a two-digit number, in every possibility, this has to be 1. So if we take even 9 and 9, 9 plus 9 is going to be 18. So this cannot be 2 ever. If we take two-digit numbers and if we add to get three-digit number, so in the worst possible scenario, even if I take 99 and 99, it's going to be 198. So the leftmost digit is going to be 1. So similarly, when we have these two six-digit numbers and when they're added, when we get a seven-digit number, so here this A is supposed to be 1. There is no other digit that can come here. So since A is going to be 1, this is 1, this is 1, this one is 1, this one is 1, this one is 1. Now, let's look at F, the units places. F plus F results in F. Well, 1 plus 1 results in 2, 2 plus 2 results in 4, 5 plus 5 results in 10. If we want sum of two digits that should result in the same last digit, well, the only possibility is 0. So we will have 0 plus 0 that will result in 0. So wherever we see F, let's write down 0 here. Next, if we look at the hundreds place, A and F, they both are known. So A plus F, that is 1 plus 0, should result in 1. But since we have a new letter here, C, it cannot be 1 because A takes 1. Which means there was a carry. And once there was a carry is always going to be a 1. So 1 plus 1, it should result in 2. Now, why is there going to be a carry? There is going to be a carry because the sum of the previous digits, it should become a two-digit number. Now, when we add two single digits, as we have already seen, the carry is going to be 1 when it is going to be something from 11 to 19. Well, basically, if we write down 1 and if there is a carry of 1, the sum was supposed to be 11. That means G plus K should add up to give us 11. So it may be 2 and 9, it may be 3 and 8, it may be 4 and 7, it may be 5 and 6. We do not know what G and K here are. So G plus K is going to end up having 11. The units place of 11 is written as the sums, and the carry becomes 1. 1 plus 1 results in 2. So A is supposed to be 1. Now, if you look at the sixth or the lakh digit, the digit at the lakhs position, which are B and A, so something plus 1 result in 1. Well, 0 plus 1 will result in 1. That is one way to go about this. But since F has already taken 0 and B is a new letter, B cannot be 0. The other possibility is when the sum turns out to be 11, so that we get 1 plus 1. That means B should be a 10. 10 plus 1 is 11, so we get 11 here. But since B represents a digit, it cannot be 10. The best possible scenario, we are going to have a 9 here. But then 9 plus 1 is 10. It's not going to give us an 11. Well, in that case, there is definitely a carry, such that 1 plus 9 plus 1 is 11, and that's what we get. Which means, from the previous sum, we should get a carry. Again, we can see that it could be 9 plus 9, it could be 9 plus 2, and so on. But since we get the sum as the 0 here, so that means the sum should be 10, because there was a carry. Sum is going to be 10 when we add the same digits. This is only possible if we have a 5 and 5. Even if we take 4 and a 4, it will give us an 8. And the carry, if there is any from the rightmost side calculation, in the best possible scenario, it will make it a 9. It won't make it a 10. Now, J and G, these are the two letters left. So let's write down the letters that have used some digits. So 1 is taken, B is 9, so 9 is taken. C is going to be 2, so 2 is also taken. D is not here. E is not here. F is 0 here, so 0 is taken. G, we do not know, but G and K, they will together make an 11. So if I take G as G, K is going to be 11 minus G. So the possible combinations that we can have are 3, 8, 4, 7, and 5, 6. Now, if we look at H, 5 is taken. So 5 is gone. So the possibilities are going to be 3, 7, 3, 8, and 4, 7. So it's going to be 3, 8 or 4, 7 in any order. Since J is there and G is going to be one of 3, 4, 7, 8. Accordingly, J will take something. Now, from the previous calculation of A plus F, that 1 plus A plus F, that results into, there is no carry. So that means G and J, they should be consecutive digits. So that means in order for G to be 3, J has to be 2. But 2 is already taken by C. So G cannot be 3. So G cannot be 3. Okay. If G is going to be 4, J is going to be 3. So G cannot be 3. G can be 7 or 8 depending upon what J is. So J can be 3, so that 1 plus 3 is 4. It could be 7, 1 plus 6 is 7, and it could be 7, 1 plus 7 is 8. So basically G can be 4, 7, 8. It cannot be 3. Since all the letters are done, so there are going to be certain digits that we are not going to account for. We do not know what those are represented by which digits. So let's look at the questions. Which digit does the letter A represent? A is specifically represented by the digit 1. Which digit amongst the digits 3, 4, 6, and 7 cannot be represented by the letter D? 3, 4, 6, and 7 cannot be represented by letter D. So basically, it depends on what G and J we are going to take. Suppose we have got we have got G, and we have got D and E. Okay, let's write down the cases. We have got D, E, G, J, and K, where G is supposed to be 1 more than G. So what we are going to do is, let's put in the available digit 3. If J is 3, G is going to be 4. If G is 4, K is going to be 7, such that G plus K is 11. Now, J cannot be 4 because then G has to be 5, but 5 is already taken by H. So when this is 4, 3, 7, D and E, they will take over the remaining digits, which are going to be from 6 and 8. Next, if J is 6, G is going to be 7, so K is going to be 4. The 7, 6, and 4 are taken, so D and E, they are going to take from 3 and 8. Next possibility is if J is 7, G is going to be 8, and K is going to be 3. So 3, 7, 8 is taken. D and E will take the remaining digits, which are going to be 4 or 6, one among these two. So we have got these 6 cases here. Now the question asked is, D cannot be represented by which letter? We can see that D can take 3, 4, 6, or 8, but it cannot take a 7. So 7 is the digit that D cannot take. Which digit does the letter B represent? So if we look at it, B represents 9. Fourth one, which digit amongst the digits 4, 6, 7, and 8 cannot be represented by the letter G? If you look here, G can only take 4, 7, or 8. It cannot take 6. So it's not possible to have a 6. So you can see that this is a good question. It's not that every letter was written in the sum. There were a couple of letters that were missing. So we had to make cases in order to answer 2 of the questions. So this was more like a puzzle than an LR set, but in CAT, such a set has come before. Well, it was quite a few years back, but still, you can expect such a set in CAT. Well, thank you everyone for joining. Make sure to subscribe to the channel, like this video, and share it with your friends. I'll see you again tomorrow with another set of LRDI. Until then, take care. Bye-bye.